briefly talk about a process called high pressure processing. This is an emerging technology that we can use to create extended shelf life products and shelf stable products that use less intense heat that you guys just saw canning, right? So in canning, you use a high temperature, right? How high of a temperature do you use in canning? 250 degrees. Okay. So when you use that high of a temperature, you're making the food safe, but you're going to have some, degradation of some of the quality attributes of the product, such as the texture and the color. So one example is, who likes green beans?
Yeah.
All right. So if you open up a can of green beans, what do you find?
Green beans.
Green beans, but how do they look? Green.
Delicious.
Green and some kind of liquid. These are green beans. These are fresh green beans. Do your canned green beans look like this?
No.
No. What happens to them?
They look a lighter green.
Lighter green? All right.
Brown.
Poke those. Are they stiff or are they really
Yeah,
soft?
they're very.
They're very stiff. So what about the texture of the green beans that you get in the can?
They're more slippery.
Slippery, squishy. So that high heat for a really long time actually causes some damage to the cell structure and causes some problems with the texture. Well, what we do with high pressure processing is we use lower amounts of heat and then we apply a great amount of pressure, a large amount of pressure. So to talk about the amount of pressure, if you were to go stand at the bottom of the ocean, the deepest part of the ocean, where you've got 6.5 miles of water on top of you feel a lot of pressure, right? That amount of pressure is less than 6 times the amount of we're applying here. So we apply over 6 times more pressure than what you find at the bottom of the ocean to the food products to get rid of the bacteria so that we can get a long shelf life and it won't make you sick. Now, a nice benefit of that is the texture and the colors and the nutritional value of the foods. There may be some degradation, but it's not nearly as bad as what you see from canning process. So we've got a few different products here that I ran this morning. If you poke them, you can kind of see a difference in the texture. These are unprocessed and these are processed here.
I want to touch the other cheese. Oh, hers are good. Right here. The other cheese. This is
So we have some cheese so hard. That's amazing.
So what you see. So the textures, it's a little bit different, right? But there's not a major difference between them if you were to compare those to what you're used to seeing in the can. Well, to make that stuff, if I can have everybody's attention over here, I want to show you the actual machine we use. To make that, we take those pouches that have been vacuum packaged, and we put them inside this canister here. And then we raise this up, and we attach it to this top part of the machine here. And then this goes down inside this big vessel here. We seal it up real tight, and we start pumping in fluids. We can just pump in a whole bunch of water, keep pumping in the hydraulic pump until we build up all this pressure. And then that pressure is going to kill the bacteria, and then you guys can eat the food without worrying about getting sick. Are there any questions?
How does it kill the bacteria? I mean, the pressure, besides the pressure. Is it killing the cell wall, or is that the secret?
No, see, most of the cell walls of the bacteria has protein, so it's going to denature the protein, like heat, pressure causes denature the protein.
Okay.
How many pounds of pressure are we talking about?
We are talking about somewhere between 87,000 to 100,000 pounds per square inch. So it's 10 times higher than the deepest bottom of the ocean. Okay.
All right, come on over
Come
here.
on over, yeah.
All right, gather around. So we've talked about what we do to food and how we can process that to make it safe and how we get rid of the bacteria. But in the plants and in the area that we are processing food, we have to make sure that we're cleaning it properly. And so we have a test that we are looking for ATP. In that opening session, they talked a little bit about ATP. Does anybody know what that is? ATP is a chemical inside of every living cell, and it's what we use for energy. And so the chemistry inside there, the molecules, the T and the P stand for 3 phosphates. And so the chemistry there will break one of those off, and that releases energy. And it becomes ADP, which means 2 phosphates. Okay, so we use that energy. Every cell uses that energy to live, to move. If it's a muscle, that's that energy that we need to move our muscles. So we have it in us, bacteria has it in it. And so when we sanitize and we clean a surface, we want to make sure that there's no ATP left. And so that's what this test is for. This test looks for ATP, and then it reacts with the chemical that is inside a lightning bug, and it lights up. And even though that's what it does, it's so little that we can't see it with our own eyes, but this machine can. And so it gives us a measurement in RLU, which is relative light units. And so it's relative to each other, and it gives us a measurement. So I'm going to give you a chance. I've got one swab for each of the groups. And what you're going to do is pull the swab out, and you're going to swab an area. As you take your fingers and you go like that, it's about 2 inches square. That's the area that you will swab. And you'll make zigzags going one way and then zigzags going the other way. And all the while you're going to turn this so you get it all the way around, okay? You can spread out all over this room and do that. Once you're done, you push that all the way down in there and you shake it all the way back to me. And then we'll put it in this machine and read it, okay? So who are my group leaders here?